Today, we are going to talk about subatomic particles and their discoveries. But before that, do we know what an atom is? I am sure you already know that atoms are the building blocks of matters. The initial thought was that substances are made up of infinitesimally small particles that cannot be divided anymore, and thus got the name atom. But things did not end there. As scientists kept working with matter, they found out that even atoms were breakable. An atom is actually made up of about 200 different types of particles. For example, electrons, muons, and mesons. These are called subatomic particles. Among these, only protons, neutrons, and electrons are permanent and are today's topic. We're still calling it atom. Hold tight, because there is an even bigger surprise. Even the particles proton and neutron can be divided into smaller particles. A proton is made up of 2 up quarks and 1 down quark, while a neutron contains 2 down quarks and 1 up quark. The quarks themselves are elementary particles, and so is an electron. Without further ado, let's begin. Electrons. One of the blessings of the modern world is electricity, and electrons are the particles that carry it through wires. Electrons were discovered by J.J. Thomson in the year 1897 through the cathode tube ray experiment. A cathode tube is a vacuum tube with negative and positive electrodes inserted in it. When high voltage electricity flows, a ray is produced known as the cathode ray. This ray was attracted to a positively charged plate placed on the tube. Later, it was discovered that this ray was, in fact, a flow of negatively charged particles named electron by Thomson. Electrons are denoted by the letter E. It has a mass of 9.11 into 10 to the power minus 31 kg, and it has a charge of minus 1.6 into 10 to the power minus 19 coulomb. An electron is almost 1,836 times lighter than a proton, and due to such a small mass, it has effective wave nature. Protons are positively charged particles that can be found in the nucleus of an atom. Protons were discovered by Rutherford in 1917. Other than the cathode ray, a positive ray was also detected by German physicist Goldstein and was named the canal ray. It was actually the flow of the positive ions of gas atoms. This ray was used to calculate that hydrogen was the lightest of all elements. Rutherford, through his alpha particle scattering experiment, observed that hydrogen nuclei were produced when the alpha beam was shot through the air. After investing with few other gases, he concluded that the hydrogen nucleus was a part of all the atoms and named it proton. Protons are denoted by the letter P. As a hydrogen nucleus without an electron is but a proton, it is also expressed as H+. The mass of a proton is 1.675 into 10 to the power minus 27 kg. It has the same charge as an electron, but opposite. That is, 1.6 into 10 to the power minus 19 coulomb. Neutrons are, as the name suggests, electrically neutral particles. British physicist James Chadwick was the one to discover neutrons in the year 1932. In 1928, German physicist Bothe and Becker found out that if alpha particles emitted from polonium is incident on beryllium, it gives off a penetrating and electrically neutral radiation. This radiation was interpreted as high-energy photons, but then something interesting happened. In 1932, Irene Joliot-Curie and her husband, Frederick Joliot-Curie, studied the then unidentified radiation from beryllium for further investigations. They found that this radiation ejected protons of high velocity from a paraffin target. Now the problem is that protons are about 1,836 times heavier than electrons. Yes, an ant might be able to carry weights 6 times their own, but imagine an ant trying to knock away an elephant. So, the neutral beam being a high-energy photon is quite unlikely. This is where Sir Chadwick comes in. He could not accept the conclusion and tried similar experiments with other elements as targets. He found out that the emissions contained a particle with a mass nearly equal to that of the proton, and named this particle neutron. It is denoted by the letter N. It has a mass of 1.675 into 10 to the power minus 27 kg and no charge. Sir Chadwick won the Nobel Prize in the year 1935 from physics for this discovery, though the Joliot-Curie pair missed their chance of getting a Nobel Prize. In this case, they got a Nobel Prize for discovering artificial radioactivity. So there is no reason to feel sorry. But this is not the end. For all we know, there might be other particles playing hide and seek, waiting to be found. By the way, the Nobel Prize is worth about 1.5 million US dollars. That was all. If you liked the video, give us thumbs up. And also, if you are new to this channel, don't forget to subscribe for videos more amazing than this. Till next time.